Okay, let's get started then. Good afternoon, everybody. I'm Munzir Dali, the director of IDSS. This is our first lecture of the spring term in the IDSS Distinguished series. This is, as many of you know, we have this once a month, and we invite people who have a very broad perspective about societal challenges that take on different approaches for analyzing them and understanding them. And today we are extremely lucky to have Professor Nathan Nunn from Harvard giving us a talk. Nathan is a professor of economics and has a lot of broad interests, particularly in political economy, economic history, economic development, cultural economics, and international trade. He covers a lot of different areas, but in particular, one area of interest to him is the historical and dynamic processes of economic development. And today he's going to talk a little bit about understanding cultural persistence and change. So Nathan, welcome, and thank you for coming.
Great. So it's great to be here, and thanks everyone for coming and listening to my research. So what I'm going to present today is one paper, which is joint with Paola Giuliano, who's at UCLA. And this paper is very much within the area of trying to understand culture. So the first thing I'm going to do, so you should hopefully see the next slide now. We're having some issues. That's okay. Yeah. The first thing I'm going to do is define culture. And so what I think of as culture are internalized values, beliefs, customs, norms about what's right or wrong. And these beliefs are transmitted across individuals. So it could be from parents to children, could be from individuals to their friends. And that's just so we're starting the definition of culture that I'm going to be using. And if we think of culture, there's been a lot of papers recently which have shown that there is cultural persistence. In other words, cultural differences that exist 200, 300, 400 years ago continue to persist today. And so the most well-known paper probably, or the most striking, is this paper by Nico Voigtlander and Hans-Joachim Voth, which look at anti-Semitic values across small German villages during the Black Death and correlate that to differences in anti-Semitic values in the early 20th century, right? So they show a persistence of that pattern. There's a large number of other papers, which I list here, which also show that. But there's a number of papers, and this comes more from anthropology or from history, of cultural change. And kind of one area one episode that's been studied within economics is the Protestant Reformation, right? And there's other examples. So these ethnographies by Margaret Mead, Raymond Firth, Joel Robbins, for example, many cases of traditional societies or societies with a traditional culture, and then missionaries coming in and then dramatically changing the culture of that society within one generation. Okay, so we have both things happening. We have a lot of persistence and then a lot of change. That just raises the natural question about, well, why is it that we have change in certain settings and persistence in others, right? So what determines whether a particular culture persists or whether it changes? So if you think about it, the closely related question is, well, what determines whether a society places high value on maintaining traditions and customs, right? You can imagine in one setting, there's some forces of change, but the society thinks it's really important to maintain the traditions. In another society, they might be more willing to abandon their traditions and adopt new behaviors. So if we're just thinking about, well, what determines this, whether society places high value or not on maintaining traditions and customs, it turns out there is an answer to this, and it's from the theoretical evolutionary anthropology literature. And so starting with Boyd and Richardson in 1985, and they provide an answer to this question, or their models provide an answer to this question. And the answer is, it's the similarity of the environment between generations. So it's how similar is the world out there from one generation to the next. Okay, so why does that matter? I'll give you an intuition. So think of a model where the state or the environment determines what's the optimal action during a particular generation. In other words, what's the optimal cultural trait, okay? If the environment is really stable, then the action or the culture that is evolved up until the previous generation is likely to be suitable for my generation. Okay, so it's evolved, it's got these evolutionary forces. My parents' generation is identical or very similar to my generation. So if I just do what they did, I'm going to be pretty well off. Okay, so I don't need to reinvent the wheel to try and figure out what the best thing to do is. In some sense, I can free ride on the information that's evolved up until the previous generation. So it's very efficient. If the environment is unstable, so imagine that the environment in my generation is completely orthogonal or unrelated to my parents, then just because a cultural trait or a custom is evolved up until my parents' generation and is suitable for their generation doesn't mean it's going to be suitable for my generation. So if I blindly follow what my parents teach me, I might actually be doing something that's really not suited for my generation. Okay, and so that's the intuition, is that culture is going to be a pretty efficient heuristic when the environment is stable, or maintaining culture is going to be an efficient heuristic. But when the environment is unstable, maintaining culture and adopting traditional customs is going to be less efficient. Okay. And so that's what we're going to test in the paper. We're going to test this empirically, but just to make sure that we're kind of all on the same page in terms of the exact mechanism, because it's a bit subtle, I'm going to go through a very simple model that just illustrates this. It's the simplest model, I think, that one can write down that illustrates this mechanism. And it was originally developed by Alan Rogers in 1988. So the model is this. This is a society consists of a large population of individuals. Each period, a new generation is born, and then the older generation dies. Okay. The new generation must choose once and for all action, either we'll call it small a or small b. And there's two states of the world. We call these cap A or cap B. Okay. And then in each state, one of the two action yields a higher payoff. And this is the payoff matrix here. So if it's state cap A, then the little a is the best action, and vice versa. Okay, so it's just extremely simple. But the state of the environment or the world is unobservable. Okay, so we don't know with certainty, or we don't know in general what the state is. And also in each period, there's a probability delta that there's a random shock, right? So the state could change. And so that's why we don't know. And when there is a shock, which occurs with probability delta, then there's a new draw from the environment. And when there's a new draw, or after a shock, there's a 50-50 chance you're in A or B. Okay, so that's just a setup, and you'll see it makes the math super, super simple. So now we're going to allow for two types of people. There's people who really value tradition and follow the tradition of the previous generations. And then there's people that don't value tradition. They say, I'm going to figure out what the best thing to do is on my own. And those are non-traditionalists. Okay, so non-traditionalists, what they can do is exert a cost, kappa, could be very small, and figure out what state they're in, and then choose the optimal action. Okay, so traditionalists, they're going to do something very different. They're going to adopt the action of the previous generation. Okay, and the way we do this is an individual adopts the action of a randomly chosen person from the previous generation. Okay, so that allows for oblique and vertical transmission, and this way traditions reproduce themselves. Okay, and X is going to denote the proportion of traditionalists in the economy. So those that value tradition and effectively use culture to determine their actions. Okay. So the model is super simple. All we need to do is calculate the payoffs of the two types. So non-traditionalists, as I said, ignore tradition, engage in trial and error, learn, and then figure out what's optimal. So they get beta every period. And then every period, because they're learning, figuring out the state, they bear the cost kappa. So their payoff is beta minus kappa. Super simple. The traditionalists, it's a tiny bit trickier, not too much. But so what they're going to do is they're going to copy someone from the previous generation. So we can start to think about what's all the ways, if someone's just copying someone randomly chosen from the previous generation, that a traditionalist is going to obtain the right action. Okay, so one way, this is the traditionalist who's copying somebody from the previous generation. So it's possible that the person from the previous generation was a non-traditionalist, and they did the right action in the previous generation. Okay, that happens with probability 1 minus X, right? Where the X is the proportion of traditionalists. So with that probability, they'll choose a non-traditionalist. And as long as the environment doesn't have a shock, right, then that action will be the right action in their generation. The other thing you could do is copy a traditionalist, but that traditionalist had copied a non-traditionalist. So that happens with probability x, 1 minus x, and there's no shock for 2 periods. That happens with probably 1 minus delta squared. Okay, and here's another scenario where this individual chooses the right action. And they copy a traditionalist who had copied a traditionalist who copied a non-traditionalist, and the environment, there's no shock for 3 periods. Okay, and so you can keep doing this, right? So these are all sequences of copying such that this person here obtains the right action and gets beta, gets the higher payoff. Okay, and so you can continue this until infinity. This is, if you just look at the pattern here, it ends up that this is going to be this infinite sequence that has this pattern here. Okay, x to the power of t minus 1, 1 minus x, and then 1 minus delta to the power of t. Okay, so with this probability here, the traditionalist is going to obtain the right action and get beta. Okay. So with 1 minus that probability, what happens, right? So really what's happened in that case is there's been a shock somewhere in that sequence. So, and remember, we made this simplifying assumption that when there's a shock, there's an equal probability you're in the 2 states, right? And so there's an equal probability that you get beta or minus beta. And so your expected payoff is 0. Okay. So the full payoff to traditionalists is going to be this. It's this, which we derive times beta, and 1 minus that times 0. Okay. And this is just using the formula for an infinite geometric sequence. Okay. And so this is the payoff to traditionalists. So if we look at the payoff of the 2 groups, there's some differences. Traditionalists, their payoff, just broadly speaking, depends on delta. Okay. And it also depends on the proportion of other traditionalists in the society. Whereas the non-traditionalists, they're just going out, collecting information, figuring out what's optimal. That's it. So their payoff doesn't depend on any of that. Okay. So what we can do to look at equilibria is just graph the 2 payoff functions as a function of x, the proportion of traditionalists. Okay. And so this is the payoff of non-traditionalists. It's independent. The payoff of traditionalists looks like this. So the way to think of this is, imagine there's no other traditionalists in society, right? And so if a traditionalist exists, emerges, they're going to copy somebody from the previous generation. They were all doing the right thing. So you get beta for sure, as long as the environment doesn't change, right? And so that's beta times 1 minus delta. Okay. So if you think of what's going on over here, this is when the whole society is traditionalist, right? So there's no one collecting information. So it's basically just a bunch of people copying each other. So we saw in this case, it's a 50-50 chance you get plus beta or minus beta. So your expected payoff is 0. Okay. And then there's continuity between these 2 things. Okay. So the interesting thing here is, as long as delta is sufficiently small, so if delta, remember, this is the stability of the environment. So as delta goes to 0, the environment is very stable. Then what you're going to have, you can see that beta is going to be greater than beta minus kappa, right? So you're going to have some traditionalists or some culture in equilibrium. Okay. So that's one thing. And then the other thing is, as delta changes, that's going to change the payoff to traditionalists. Okay. And so the equilibrium here, I should have said this explicitly, is this point here. Okay. So here traditionalists have a higher payoff, so they would increase in the population until you get a point here. Here, non-traditionalists have a higher payoff, so they would increase. In other words, the traditionalists would decrease till you have a point here. And so this is a stable equilibrium. Okay. And so as delta increases, this is going to shift down, right? You can see that. And then the proportion of traditionalists in the society is going to decrease. So this is the prediction of the models where the more stable the environment is, the greater the proportion of traditionalists. Okay. Or sorry, yeah. Okay. Any questions? about that. Okay. So if delta is sufficiently high, then the society has no traditionalists, right? So delta is instability. And then in an equilibrium with both type present, the greater is delta, the lower the proportion of traditionalists, okay? So the variability of the environment is basically going to decrease the proportion of traditionalists in society. In other words, the more stable the environment is, the more traditionalists there are. Here, the stronger is culture. Okay. So any questions about that? Okay.
I have a question,
Yep.
Professor. Thanks. I probably need to think about this even more carefully, but because there's only two states of the world, Cap A, Cap B, is it possible that you would have a non-traditionalist copy somebody who had it wrong in the previous period, but then there's a shock and they, just by luck, get it right? And is that something that you have to be careful about here, or does it matter because it's so improbable?
No. Yeah, so that happens basically, and so that would be kind of within these cases that you can see your expected payoff is 0. So that means half the time you get it right in general. So anytime there's a shock, it's because we're having equal draw from the two states. Half the time you get it right. Yeah. So you could be wrong, then you get a shock, and then you would have got it right. Yeah, you would have got it wrong if there wasn't a shock, vice versa. Yeah, and so I think all of that fits into this scenario here. Yeah. Okay. Yeah. So the main thing is the greater the instability of the environment, the higher, higher delta means less traditionalists. Okay. And so just really quickly, so one interesting aspect of this is that culture provides this way of free riding and figuring out what the right thing is to do without actually figuring it out. And so there's lots of cases like this in the world where people adhere to traditions, and the traditions have benefits, but people don't know, right? So they're only basically doing something because it's evolved over time and they're copying previous generations, but they end up being reasonably well off. And so one example of this, which I always like to cite, is alkali processing of maize. And so this is the way that maize is processed in much of the Americas. And if you have a diet that's based on a large proportion of corn, basically, you'll get a disease called pellagra. And so this is because corn doesn't have enough niacin, so it's a dietary deficiency. But if you process maize like this, which is basically to throw ash or dirt into the water when you're cooking it or when you're boiling it, what this does is helps the body to absorb the existing amounts of niacin that are in the corn, right? And so this has been studied. There's a number of papers looking at this, and societies which obtain a large proportion of calories from corn actually tend to have this form of processing. So it's not that they know. This wasn't understood until about the 1930s, but this is just a tradition that's evolved over time and has benefits, right? And so this just highlights the benefits of tradition. Okay, so the basic test of this, so now that's kind of the theory. The basic test of this is going to look at societies or countries and see, is it the case that those societies that had an environment that was less stable historically, so that their ancestors face, an environment their ancestors face, does it seem like this affects the extent to which culture is persistent or the extent to which tradition is adhered to? Okay, that's kind of what we're going to look at. So the measure one thing we need is a measure of climatic instability, okay? And it's instability across generations. And so we take this, I guess, just as an economist, it's nice from an empirical point of view because it's exogenous. So we don't have to worry about this variable affecting or being affected by human behavior. Okay, so this is natural changes in the climate. Okay, and there's a lot of evidence that climate or weather affects things and has real effects on things like income, health, city size, etc. Okay. And so the data we're going to use is from two sources, and the sources have their pros and cons. So one is gridded weather data. This is at 5-degree resolution, and it's global though. That's the benefit. And it's back to 500 AD. And it's reconstruction from tree rings, ice cores, a whole host of proxy data. Okay, so we have it globally. It's at a pretty coarse resolution, only 5 degrees, and the annual resolution is not great. Okay, so there's an alternative source which is at a 5-degree resolution, or sorry, a 1/2 degree resolution, 55 kilometers, but it's only available for North America only. But it's also, its measurement at the annual level is quite precise, okay? And this comes from tree rings. Okay, so these are the two sources we'll use. So for both, we have measures of either temperature anomalies or drought severity. So these are just summary statistics of changes in weather. And we have the raw data, which is measured annually. And so what we do is calculate summary statistics at the generational level. And so we define a generation to be 20 years. Okay. And we're going to do two things depending on which data set we use. For both, we'll be able to calculate the first moment of the annual data. So what is the mean drought severity or mean temperature within a generation? So there's 70 generations within this time period. And then we'll also be able to look at the second moment of the data. So what is the annual year-to-year variance of that generation? Okay, so these are two summary statistics of what is the world like, or was the world like during that generation. And these will be measured at the grid cell level as well. And then what we're going to do is just look at the standard deviation or the variation in that statistic across generations for that grid cell. And so that'll tell us how variable was the environment, either the first or second moment of a generation, of a grid cell across generations, okay? So that's what this is here, is basically for a grid cell, how much did those summary statistics vary across the 70 generations for which we have data. So here's just some data, just to give you a sense. This is the global sample, so the Mann et al. Data. This is the raw data. So this is hand-picked just to be illustrative. This is from Central Africa. Okay, so this is a location for which we know there's a fair amount of stability. Then we calculate the generational averages, right? And then we're going to look at the standard deviation of this. So this is going to have a low measure of variability. Here's southern Sweden, which has a high measure of variability, okay? And so we calculate the generational averages, and we're going to take the standard deviation, okay? And the North American sample, again, two populations, same thing, right? So you can see kind of the variation in the raw data, then we calculate generational averages and then look at the variation, okay? And so when we do this, this is the variation that we have, or the differences in grid cells globally. And so a darker color means less stability, more instability, okay? So there's, lots of variation here in determinants. There's certain things like closer to the equator, you're going to have more stability. Further from the equator, more instability. Ocean water tends to be more stable. And so there's a lot of determinants. At the same time, you can see that grid cells close to each other can have very different measures if there's mountain ranges or other determinants or other factors. Okay, so we could talk for a while about the exact processes that generate these data. But because time is short, I'm just going to take this as given for now. Okay. And then this is the North American sample. And so again, you see variation. This is a much finer resolution, 1/2 degree. But again, this is the type of variation where a darker color means more instability. Okay. Okay, so what we're going to do is we're going to have data from today that basically is individual self-reported importance of maintaining tradition, or revealed importance of tradition by whether we see cultural persistence. So some of the analysis is going to be at the ethnicity level, some is going to be at the country level. And if we want to measure my ancestors, so how stable was their environment, and we're going to connect that to myself using my ethnicity. How do we do that? Well, for ethnicities from anthropological sources, we know their historical locations. So think of this as the 19th century or 18th century, their historical locations or their traditional locations. Okay, so you see there's a lot of Indigenous Native American ethnic groups here, a lot in Africa, and then some in Europe. And so these are three different sources. Okay. And so we're going to use this information, the location information, to link an ethnic group to a grid cell. And then that'll tell us basically that ethnicity, their ancestors, how stable was the environment that they faced. Okay. And we have three different sources. I won't go into the details, but Ethnographic Atlas, and then two additional extensions of it, which have recently been developed. Okay, so that's at the ethnicity level. So we'll have some individual level data where people report their ethnicity. For other data, we'll only know the country, actually. We won't know the ethnicity. So we want to construct a country level measure of this. And so this is for individuals in a country, on average, how stable was the climate faced by their ancestors? Okay, so how do we do this? This is a bit slightly more involved. We take each of the 1,300 ethnic groups in the ethnographic sample, and then we link it to this, this is a map of the world, and it's basically all the languages and dialects around the world. Okay, and so it's about 7,000, a little over 7,000 languages and dialects. So we've linked each of these ethnic groups to a language dialect, right? So here might be Hausa, and which is a language and dialect today. This is the map of where people who speak Hausa are located, and we link it to Hausa in the past, so we know where the Hausa were located in the past. Okay, so for that group, it's going to be pretty similar, but there's other groups like English, right? So that's going to be linked to England, and that'll be the measure of ancestral location, and we'll measure instability in that case. Here, Portuguese will be the Portuguese here. And then these are a lot of indigenous languages. Okay. So once we do that, this is basically what the map looks like. This is a measure of instability on average across countries, right? And so this is trying to get a proxy of, for Americans, what is the average instability that the average Americans' ancestors faced between 500 and 1900, okay? Yeah, and so that's kind of what the measures look like, okay? Okay, so that's our primary instability measure. Any questions on that before I go ahead? Okay, so then the last thing is just the tests. So we're gonna have 4 tests, which I think they're all quite different, and we'll see that they kind of paint the same picture, which is consistent with the predictions of the model, that basically more instability weakens the importance of tradition, okay? And so one thing we're gonna do is measure X directly. So the self-reported importance placed on tradition. And so we'll do this with survey questions, we'll see that. And then the other 3 things we'll do is actually have revealed measures of the importance of tradition by looking and seeing whether culture persists, okay? So one is we're just gonna look at the country level, look at things which have changed over time, like female labor force participation, polygamy, cousin marriage, and see, is the rate of persistence different depending on these measures here, the ancestral stability of the environment, okay? And then the other thing we're going to do is look at immigration and use that as a natural experiment, okay? And so look at children of immigrants, do they continue to follow the same traditions and values, or traditions and norms of their parents and of the populations back home? And so do they marry within their own group, and do they continue to speak their ancestral language, okay? And similar idea, but with indigenous populations of North America, do they continue to speak their indigenous language, okay? And then these last predictions about the change in cultural traits, basically this is generated directly from the model. This is basically tells you how quickly is there a change when there's a change in the state of the world from one action to the other, right? And you can see that it depends on the underlying proportion of traditionalists in the society. So when there's a lot of traditionalists, then cultural change is much slower, okay? and there's more persistence. Okay, so any questions about that? Okay, so the first thing we're going to do is measure, just very simply, measure directly the importance of tradition. And this is from the World Values Survey. The respondent is given a description of a person. The tradition is important to this person to follow the family customs handed down by one's religion or family. Okay, and then the respondent chooses how similar is this person to them, or does this statement reflect them? Okay, so we'll just create a variable that ranges from 1 to 6. And I won't go through all the details just because of time, but think about one regression we're going to look at is across countries. Okay, and if we look at country level averages, basically this is the relationship here. So the greater the instability, the variability of the climate of my ancestors, the less important tradition is as reported in these survey questions. Okay, and so this is just the raw data. Actually, there's nothing else going on, and in the raw data you can see a pretty strong negative relationship. If you run regressions, control for a host of geographic and ethnographic characteristics, you find the relationship persists. And this is just using the different ethnographic sources. Okay, so it's about 75 countries that we have data for, but you find that this correlation is robust. Okay, so the other thing you can do is actually run an analysis where you look across individuals and you look at the same individual or different individuals, but within the same country, but they're from different ethnic groups. So now we're linking an individual to their ancestors' instability by their ethnicity. Okay, and so we're controlling for here country fixed effects in all of this. Okay, so it's using very different variation, a variation that's orthogonal actually. So this is within country variation, and you see the same pattern here. Okay, that if I had ancestors who were exposed to a very variable environment, I'm going to think that it's less important to maintain traditions that are passed down from generation to generation. Okay, so the second test is kind of returning to this, what's often called the persistence literature. And so I talked about the paper by Nico Voigtlander and Hans Joachim Voth, where they looked at a cultural trait in 2 periods of time. So this is early 20th century and then the 14th century during the Black Death. And this would be a typical regression from the literature. Let's show that a cultural trait in the past matters for today. So what we're going to do here is we're going to change the estimating equation slightly, and we're going to allow that relationship to differ depending on the climatic instability faced by an observation's ancestors. Okay, and so in this case, so we're effectively allowing the persistence to differ depending on the climatic instability. Okay, so basically, when there's less stability, more instability, you should find that the persistence of the cultural trait is less. In other words, beta 2 should be less than 0. Okay, so we have less persistence when there was greater instability. And so that's what these are showing you. This is looking at female labor force participation in 1970 and then correlating it with female labor force participation in 2012. This is across countries, across 77 countries. And you see a coefficient of 0.33. Okay, to some extent, 1 would be perfect persistence. 0.33 is imperfect, but it's still high. And if we allow this to interact with climatic instability, what you find is a positive coefficient here, but the interaction is negative. Okay, so what does this tell you? The instability measure ranges from 0.05 to 0.5. So for the most stable country, the persistence coefficient is going to be 0.6. For the least stable country, according to this specification or to these estimates, it's essentially going to be 0. Okay, so this kind of has a pretty big effect on the extent to which we observe persistence of female labor force participation in the real world. So we can repeat the same exercise, but rather than female labor force participation in 1970, we look at female labor force participation during the pre-industrial period. Okay, and so we construct a measure. They're all normalized so that they're on the same scale, and you see the exact same pattern here. Okay, we can do the same thing, but we look at polygamy today and then polygamy in the past using the anthropological data, and you see the exact same pattern. Same with cousin marriage, right? And so you see the exact same pattern, right? So these societies that had ancestors that had a less stable environment, we see less cultural persistence amongst those groups. Okay. Okay, so looking at immigration, so it's very simple. We take the census, and we're going to look at individuals who, the first case, who are married. Okay, so and these are individuals who are married, but their parents were born overseas. So they were born and raised in the US. We're even controlling for MSA fixed effects, location fixed effects. So they live in the same location, born and raised in Dallas, Texas, for example. But some individuals have parents that are from Italy, some from Sweden, some from Nigeria. And the origin country is going to give us a measure of ancestral climatic instability. Okay. And what we want to see is, does basically that climatic instability affect whether individuals marry within their same group? Okay. And so I think it's just easiest to see just in the raw data, actually. So this is climatic instability in the origin country on the x-axis. And this is a sample of married women. This is the proportion of them that have the husband from the same country of origin. Okay. So you can see that where there's less instability, more similarity, then you're more likely to maintain the tradition of marrying within your group. Okay. And so this is has the countries labeled. This gives you the size of each country within the sample. So this is Mexico. So a lot of the population is Mexican within the US, right? So you still see the same pattern. So skip the regressions and look at language. So same idea, but the outcome is, do you speak the ancestral language at home, right? Your origin language. So I'll show you the same country level plots. And so again, if your environment, your ancestral environment was more stable, right? So tradition is more valuable, you're more likely to speak a foreign language at home. Okay, and this is population weighted, right? Okay. Okay, any questions about that? So you can run regressions and you'll find similar pattern. There's some interesting things here. I won't go into the details about transmission from fathers to sons, or actually fathers to children or mothers to children. And you find the exact analogous thing that we saw before about transmission being weaker when there's greater climatic instability, right? Okay, and then just the very last thing before I finish is examining Indigenous populations in the US and Canada. So one thing about immigrants is they're definitely a non-random sample of individuals from the origin country. In fact, you might think their selection into emigrating to the United States probably has to do with how much they value tradition, right? If you don't value tradition a lot, if you're more open to new experiences, new things, you're probably going to be more likely to want to emigrate to the US. So it's a very select sample. So this is why I like this other group, which is Indigenous populations in the US. Okay, so like immigrants, they're facing a new culture and they need to make decisions about, do I adapt to the new culture? To what extent do I hold on to my traditional values and beliefs or traditional customs? But there's not the same selection, right? They haven't chosen to move to the United States. They've had instead the Western European culture hoist upon them. Okay. And so we're going to look at the same thing as whether individuals from these different indigenous populations continue to speak their traditional language. And so we'll use the US Census, right? 1930, 1990, and 2000. So that's all available data. And then also a Canadian census from censuses from 2001, 2006, and 2011. And the Canadian censuses are only made available at the reservation level. Okay, and whereas the US censuses are made available at the individual level, so the analyses are going to be slightly different. So we'll see that. So here's the locations of the indigenous ethnic groups and overlaid with the climatic instability measures. That's Canada and that's the US. And so for the US, we can run these regressions at the individual level. We have location level fixed effects, and we know whether an individual speaks their native language, and we also know their ethnicity. Okay, and so this is basically the estimates that if your ancestors had a more unstable environment, you're less likely to be speaking your indigenous language at home. Okay, and we see the same patterns I mentioned before about transmission, which I won't get into, but you see those exact same patterns amongst indigenous populations. Okay, so now we can look at Canada if we're willing to go to the ethnicity and location level, right? So we're not at the individual level, we're at a slightly more aggregated level. We'll still have location fixed effects. Okay, so we'll still be looking at individuals from different tribes or ethnicities, but in the same location. Okay, and you see the same pattern. So is an indigenous language spoken at home? The Canadian data has 3 measures of ability to speak your indigenous language. And then here is when we pool the Canadian and the American data together. Okay, we get the same patterns. Okay. So the very last thing we can do is to turn to the Cook data. And remember, this was the finer data that's at a much finer resolution, and it has annual data that we really trust. So we can calculate the variance of weather within a generation. Okay, and so we're not just going to be looking at the mean, but we're actually going to look at the variance. And so when we do this is the stability of the mean. So just redoing what we did before, but with the finer data, looking at is an indigenous language spoken at home? So instability means it's less likely that you're maintaining that tradition. And then here's kind of the interesting thing. We do the exact same thing, but it's not the variability of the mean. It's the variability of the year-to-year variation of the standard deviation. Okay, so it's the exact same thing, but not privileging the first moment of the data, but saying, okay, let's see, do we see the same thing for the second moment? Okay, and you see the exact same pattern. This is with the individual level data, and then this is with the more aggregated data from Canada as well. Okay. Okay, so I think I'm out of time. So so all of this lines up. This is, I guess, to some extent, a very economics-y paper where you take one question and you kind of beat it to death with all the data you can throw at it, and hit it from every angle until maybe someone's slightly convinced. To me, so just taking a step back, why is this interesting? I think we're really just trying to understand, within economics anyways, culture, and thinking about it in a theoretical sense. There's been these models in evolutionary anthropology way back to at least Boyd and Richardson, but even earlier. And there hasn't been a lot testing these models, right? These models, they're important because they actually tell us why culture would arise, why it's efficient to have traditions and to follow the traditions. And, I think this paper provides a test of those very basic models, which are, analogous to supply and demand in economics. And then just the one other thing I wanted to say is the very last point here is, for empirical reasons, I take the instability as being exogenous, and so and want an exogenous source of instability, so I use weather. But actually, we can think of lots of sources of instability being endogenous, right? Technological innovation leading to more instability, and then that would lead to less of a reliance on tradition. And you can think about settings in which you get these multiple equilibria, right? So one society has a lot of innovation, so things change, so traditions aren't followed. That leads to more innovation, and that's a self-fulfilling, stable equilibrium. Other societies might be more stagnant, so there's not a lot of innovation. You rely on tradition. That generates more stagnation or less change, and that's a stable equilibrium as well. So I think that's also very interesting to think about, right? And it's kind of a way forward for economists in terms of thinking about things like innovation. So I'm happy to answer any questions that there might be.
Thank you, Nathan, for a great lecture. If you have questions, either you can raise your hand on Zoom, or just start talking. It's a small group that you you can do that.
I wanted to jump in with a question. So
Yeah.
I think it's related to some of your concluding comments, Nathan. So would you argue that you're agnostic to whether being a traditionalist or a non-traditionalist is better? Like, would you say that the non-traditionalists are better, or it depends? And I guess I'm asking because, okay, we see this persistence, we see how the role of environment and what it means for changing tradition, but what's actually the effect? Does it lead, is it better to be a non-traditionalist? Where is it better to be?
Yeah.
In terms of outcomes, like growth or other things. I mean, I guess you're kind of trying to get at that in the next stage, but I'm curious to see how you're thinking about it.
Yeah. I think, if we return to the model to some extent, or if we think about the model, so in equilibrium by definition, traditionalists and non-traditionalists have the same payoff, right? So then, so within a society, you can't really say, oh, it's better to be a traditionalist or a non-traditionalist. And that kind of makes sense from an equilibrium point of view, because if one was better, then you would have entry into that group. And then, so that's one thing. And then the other thing as well, though, is, well, what if a society has more traditionalists at the society level? Is that society better off than another? And in the model, if you remember, there's a flat line and then a curve, and then the equilibrium is where they always cross. And so the payoff, no matter what proportion of traditionalists, is always determined by that flat line, which is beta minus kappa, right? So in that model, strictly speaking, payoffs of a society are the same, regardless of what proportion of traditionalists there are. But that's an artifact, and there were a number of papers by Boyd and Richardson and Rogers. It's an artifact of how simple that model is, right? So there's been a number of papers developed where, well, actually relying on tradition saves costs and makes, other things more efficient, and there are benefits. And so the society that relies more on tradition is going to be better off. And actually Joseph Henrich, who's at Harvard in the Human Evolutionary Biology department, has a book called The Secret of Our Success. And so why are humans different than other animals, including non-human primates? And for him, it's because we have culture and no other animal has culture, right? And so, so I think all of that would suggest with culture, we're better off, definitely. And so, but I think that needs to be tested to some extent. And then the implication is, well, it depends on the stability of the environment as well. And so that would need to be tested. Yeah.
So maybe a follow up on that question, Nathan.
Yeah.
So in thinking about immigration, for example, how do you control for the attitude of the hosting country to subgroups? You think about maintaining a language, for example, well, it does matter whether this country is actually friendly or not friendly to that particular group, and actually sort of getting the reaction.
Yeah. Yeah, that's right. So in the analysis, I kind of, sped through it. We definitely want to control for things like the genetic or linguistic distance of the US to these other groups, because exactly, due to the mechanisms that you're suggesting, that's going to be important, right? How willing certain countries are to learn English or to have their own enclaves is going to be important. And I think, and similarly for marriage, are there other immigrants within your community that you could marry? And so that's obviously going to be important as well. But I think there's a whole separate set of questions in line of analysis about things like integration, backlash, these sorts of things, which are related to the relationships between the host community and then immigrants. And so there's a lot of interesting stuff that's been done by Vicky Fuka, who's a political scientist, for example, at Stanford, looking at backlash. And I think we're really trying to understand the contact hypothesis is clearly relevant. And so, so there's a bit with our data that one could do to dig into this more. And we've just kind of had that as nuisance and wanted to control for it. But as you're pointing out, it's super interesting in and of itself. And we should do more. Yeah.
Thank you. Any other questions or comments from the group?
So I have one question.
I see a hand up. Yeah. Okay.
Biff, I think it's you.
No, someone else can go who began.
Sorry, so is this my turn?
Sure.
Yeah, you can go ahead, Bharadwaj.
Yeah, so I mean, so you looked at one side of the problem where you look at how culture is affected by or persistence is affected by the environment. But then you also have a feedback where the culture kind of determines the environment, right? So it has an effect on the environment on the subsequent iterations or the next generation. So if you incorporate that kind of an effect where you also look at the effect of culture on the environment, do you think you would get qualitatively different conclusions or?
So that's just basically one thing I did because I was curious exactly as you are. What happens if culture affects the environment? And the intuition is, well, if there's a lot of tradition, right, and people don't want to experiment doing different things, then the environment will be stable. But then that'll cause the return to tradition to be high. And so that can be one stable environment. So it turns out, remember in the model, there was one equilibrium. Turns out if you do what you were thinking, you get two equilibria rather than one. And one equilibrium, the environment is stable, so tradition is strong. And the strong tradition means there's no innovation, so that means the environment is stable. And there's another one where the environment is unstable. Tradition is weak, so people experiment a lot. That leads to innovation, that causes the environment to change. And that's a stable equilibrium as well. So I have a handbook chapter called History is Evolution, where I kind of just work out that very simple example. And there's some people like the economic historian Joel Mokyr, who argues that's what happened with the Industrial Revolution. An important thing was that scientists, academics kind of learned that it's okay to question your advisors. So it's like grad students weren't allowed to question their advisors before that. And then because, that was just not allowed, you couldn't question tradition. And once society started to be able to question tradition, tinker, do things differently, then you had all the innovation that you had during the Industrial Revolution. And so, yeah. So I think it's a great point that you're bringing up, and and we studied much more beyond the little that I did.
All right, we take the last question from Bill.
Yeah, thank you so much. This is super fascinating. I was wondering with the data, if there's any, threat that cultures that have changed too quickly cease to exist. So you sort of have like whether or not you can like measure, ethnic groups that are, no longer represented in modern data, and how that would, whether you think that could impact your findings in any way, or if there's like some sweet spot where these are cultures that have survived to some extent. I don't know.
Yeah, that's great. That would be a great research agenda to try and understand that, is to think about, instability and the environment changing and shocks, and whether it's related to the previous question about, is it better to be more flexible or less flexible, right? And so that would be one way, now that you mention it, of getting at that quantitatively, is to go back in time and seeing when different societies have been hit by shocks, then basically to what extent are they able to survive. And it's a bit of a tricky, like, philosophical thing, because if you change your culture in order to survive, then do you still exist as a separate society, right, or as a different group? So probably the answer is going to depend on how you view that. So yeah, if that makes sense.
Okay, well, we're coming to the end of the hour. Again, thank you so much, Nathan, for a wonderful lecture, and thank you all for attending today. I'm sure that if you have more questions, you can shoot Nathan an email or something and ask. But this is wonderful work, and we look forward to more conversations. Thank you so much.
Great. And thanks so much for having me and for all the great questions.